Hey, what's happening, guys? Today we've got an unboxing and demo of the SA6 6 gigahertz portable spectrum analyzer and signal generator. So this is a 35 megahertz to 6 gigahertz spectrum analyzer. I'm sure you guys are all familiar with the Tiny SA. Well, the Tiny SA is really good. I think it's up to like 1.5 gigahertz or something, but it goes down low enough to cover the amateur radio bands. This picks up where that one stops. It's a higher setting of frequencies. So this is the manual. Is there anything interesting? Here are specs. Feel free to pause it for as long as you want. Switch on, off, power on. When the device is off, press and hold the power button for 2 seconds to turn it on. Well, it doesn't say much. So what do we got in the box? We have one RG316 cable. Oh, no, there's the other one. I was going to say, I thought there were supposed to be two. These are stiff, but I mean, that don't really matter. And then we have a female to female coupler, which is nice because I didn't have one of those. So I will add that coupler to my box of RF shenanigans. There is a, well, that's really nice long USB-C to USB-A type cable, and a guitar pick type touching. Look at this. This is really nice. That's a really nice stylus, yeah. Cool. Wow, that's heavy. Holy cow. This is very important, RFN plus 10 dB max, where you will blow out the front end of this thing and she'll never sing again. On this side we have RFN, signal generator out, type C, power. I'm not sure what that little Das blinking light is there. Let's have a look at it. Should say what it was on here. Number 5. Battery charge indicator. Okay. So let's power it up. There we go. Errant. That was very quick. I couldn't see what it said. It said Ernst something on there. The firmware, you know. Oh, I hate that. Guitar makers do that, especially Fender. So let's see. The device is quite larger than the Tiny SA, but I'm just wondering how much more screen real estate do you actually get in the box? And yeah, there is some. Let me grab a measuring implement, and we'll take a diagonal measurement of these screens quite carefully, because I don't want to scratch them. So here's the Tiny SA, and this is the cheap Tiny SA, the $49 one, not the Tiny SA Ultra. So that diagonal is what, 74.4 millimeters. Yeah, and that one is 82 millimeters. So there is some more screen real estate. And honestly, I don't like this little box. I like the Tiny SA, don't get me wrong. The box is just too small. This is more of a usable size box, in my opinion. Of course, my opinion could be crazy too. So let's tap a Rooney on her here. You can see turn off some lights. You see our spectrum display down here. With no antenna attached, we're not going to hear much, but luckily I keep my feathers numbered for just such an occasion, and happen to have here an SMA type antenna. So we can take off the dust cover there and thread this guy on. And I'm going to tell you right now, probably the only thing we're going to see is one broadcast FM station at 103.5 megahertz. That's really the only broadcast station that makes its way down into the valley that I live in. Which, depending on the type of music you like, is either good or bad. Alright, there we go. I don't see much of anything at all. Alright, let's go. Okay. Frequency. Menu. Alright, here we go. Frequency. Center. We'll put our center frequency at 100 megahertz. Span is 10. Stops. Good. Yep, and there you see it. 103.33. So don't worry, we're going to take a look at some stronger signals. But let's just talk for a quick second, if you're unfamiliar with a spectrum analyzer, as to what it is and what it does. All right, so if you're watching my channel, you played around with electronics a little bit. So you're familiar with some of our other test equipment, like the multimeters and the oscilloscope. Well, you can think of this as kind of a relative of the oscilloscope. It has the same kind of screen, sort of, but they just show different axes. An oscilloscope shows you voltage here in this vertical axis against time in the horizontal axis. So if you have a sine wave, you'll see it move up and down across here because this is time. This is whatever your sweep time is. This is 0, and that is the max sweep time. Well, this is different. This in a spectrum analyzer. This is amplitude. It's still showing you, the called the value of the signal, the strength of the signal. Okay. But where an oscilloscope is linear, 1, 2, 3, 4, 5, 6, 7. This is a logarithmic scale. You see minus 70, minus 60, minus 30, minus 40, minus 30, minus 20, minus 10, 0. And then we go up to 9. We're not going to get into the dB scale today. But this is a logarithmic scale. And the reason you use a logarithmic scale on a spectrum analyzer is because it allows you to see what can be a very small signal, like right there, that little radio signal, just kind of peeking in every once in a while, next to a larger signal. Like think of the oscilloscope example again. If you tried to put a 1 volt peak-to-peak signal on one channel and 100 volt peak-to-peak signal on the second channel and view them at the same time, either you're going to have to attenuate the 100 volt signal to the point where it almost becomes a flat line, or you're not going to be able to see them both on the same screen. By using a logarithmic scale, we're able to see large values and small values next to each other and be able to compare them to each other. You see, the voltage scale says 0 volts down here in the bottom. But with the spectrum analyzer scale, we start at a higher number, which is a negative and a weaker signal. And these numbers are comparative to each other when there's more than one on the screen. So this now is the frequency domain. And we can start, all the way down here from 35 megahertz, which is the low end of this. And we can take it all the way up to 6 gigahertz and see everything in there all at once. And that's the beauty of a spectrum analyzer. It takes just a big old bite of the spectrum and shows it to you all at once. Kind of cool. And I'll give you an example of that here in a second. So the controls on here, we have marker, menu, frequency, and amplitude. Let's hit the menu here, and that brings up this main menu thing. So presets, 250 to 750 megahertz, and then we can set other presets that we want as well. Device, this is the device. We can turn Bluetooth on or off. I'm going to turn it off and save some battery. We have idle shutdown. Oh yeah, we definitely want that. Again, to save battery. Yeah, if I'm not using it for 3 minutes, shut it off. We can shift the frequency to match, because this is digital synthesis, which should be pretty accurate, but because it's digital, we can shift it a little bit one way or another. Same with the amplitude. All those things will work hand in hand. Now here is our frequency generator. We can turn it on, we can turn it off, and we can turn the tracking on. Tracking is the frequency generator signal or pulse, or whatever you want to call it, will follow along with the sweep of the spectrum analyzer. So they go together. And I'll give you a demonstration of that. And then we have our frequency. In this case, it is 1500 megahertz, 1.5 gigahertz. Wow. Let's see how low it'll actually let me set. What if I tell it I want 1 megahertz? Yeah, that's what I thought. I just wanted to see. So yeah, 35 is going to be the bottom. And then we have power levels, minus 25 to minus 15. Sorry, I keep bumping the camera. We have markers. We can do different types of markers, and we'll talk about them. But we can mark up to 4 different signals on the screen at one time and be able to compare them to each other. That makes that a really useful thing. Amplitude. We can set up how the screen is going to look. Grid steps can be 5 decibels or 10 decibels with a ZN of 50 ohms or 75 ohms. Pretty much everything I'm going to do is going to be 50 ohms. I'm not sure what other than television actually works at 75 ohms. Hey, if you know, tell me. I'd like to know. And then our reference amplitude of 9 dB. And our scale is dBm or dBUV, which is microvolts. Then we already got a nice little example of the frequency here where we can set it. 2 ways to set the frequency in a spectrum analyzer. You can do center and span or start and stop. Like if we want to go see the maximum span here, we can say start at 35 megahertz and stop at, what would it be, 6,000 megahertz? Yeah. So now we are seeing a bite of the entire spectrum that this thing is able to see. And unfortunately, taking that much of a bite, we have really slowed things down. So that's really not optimal. And I'll talk more about that when we talk about setup and use. All right, I set it back to a more reasonable level. We're going from oh, it didn't listen to me there. Huh. Frequency, please. Start at 100 megahertz. There we go. So now we have our start at 100 megahertz. Our center is at 150 megahertz. And our stop is at 200 megahertz, with a span of 100 megahertz. We have 968 points about this scan. So, each one of these lines is actually a dot, a point. And it's taken 98 milliseconds. We have attenuation of, looks like, man, I can't read that. It looks like minus 29 dB reference. Now, the one thing that I don't see any control here for, whoops, and that is resolution bandwidth. Yeah, change that to 10. See how that looks? Device. Yeah, there's nothing for resolution bandwidth on here. That kind of stinks. Resolution bandwidth will change this sweep speed through here and make it appear either smoother or not. Now, another thing you're not seeing here is a waterfall display, which would be like here's this really strong signal right here. Let's put a marker on that. So let's see, trace, max trace on. Oh, that's like a max hold. I thought I was turning a marker on. Max trace, we don't need that. Marker 1, peak 1. It's not working. I'll show you why it wasn't working. You just have to turn it on. My bad. So now we have our marker. And you can see up here it is labeled as peak 1 at 186.2 megahertz. So that signal there at 186.43 at minus 60 dBm is part of the 3-band, it's called. And in North America, that is used for television broadcasting. It looks like it's used for television broadcasting in Europe and Ireland as well. And then the rest of the world for digital audio broadcasting. So now we know something about that signal, which is kind of neat. Okay, so you can see the TV signal there, and it is a very low signal. Again, minus 62 decibels. Now, if you watch this area right here, you might see a signal that is considerably more powerful appear. Now, that signal at 146.4 is at minus 24. And this is what I mean when we're talking about we can see large signals and small signals at the same time on the screen. That's what makes the frequency analyzer such a useful device. So if you work with RF or, have a hobby in RF, or you're a ham or shortwave radio listener, spectrum analyzer is a wonderful tool to have in your kit. Now, if you are a shortwave listener, this is not the one for you because shortwave is all below the 35 megahertz. This is above it. So who is this for? This is for people who are messing around in the higher end, like VHF, UHF. What's above that? Then they're like ultra high frequency. That's UHF. VHF, UHF, super high frequency or something, and then clear up into the 2.4 gigahertz range and the microwave range. In fact, let's take a look at what kind of 2.4 gigahertz shenanigans is going on here in my house. So we'll go center frequency of 2400 megahertz and a span of, we'll just do like a span of, I have no idea what the band range is here, so go ahead and laugh at me. I'm going to go 20 megahertz. So you can see there's all sorts of little things going on here, but they are very low, and that's probably because my antenna isn't really resonant for 2.4 gigahertz. So there, by shortening it some, you can see we're getting a lot more. And these are very high-speed verse signals. But, if you're somebody who works with that, you know what's going on, right? So what are my initial impressions? My initial impressions are, this is a lot of kit for very little money. A benchtop spectrum analyzer that can go up to 6 gigahertz is going to cost you a pretty penny. Let me give you an example. Just a quick look online showed me the Regal RSA 5000 series for about $8,000. But that $8,000 isn't all for the frequency. It is also for the analysis that you can perform with a device of that caliber. This just doesn't have the capability to do that. It does have a lot of great basic capabilities, but let me put it this way. If you need an $8,000 6 gigahertz spectrum analyzer, your company is probably going to provide it for you. This is not something you'd be buying out of your pocket. So if you need something to look around, see what the RF spectrum looks like in your area. Maybe you have problems with your Wi-Fi, or perhaps you could be an amateur radio enthusiast or a shortwave listener. All of these things, this is the kind of tool that you need to use to look at seeing what's coming in, what's going out. For instance, I guess I didn't pay enough attention to it. It left me just like my ex-wife. Let you see what's coming in, see what's coming out. So say, for instance, you have a VHF radio, like this is, what this is. A couple watts, right? So let's say you put on, you take off the antenna, and you can screw in that coupler that came with it. And then you can screw on the RG316, like so. Unclench your butt cheeks, Barry. I'm getting there. And then, you could come into your spectrum analyzer. But listen, friends, if you do this, this thing's going to go kaboom. I'm not sure if this is like a 5 watt or a 2 watt, but oh Lord, that's way more than this thing can handle. If you're going to do something like that, you are going to need attenuators and lots of them. But basically what I'm saying is, with the attenuators, you can hook a radio up into here, see what its spectral output looks like. Is it clean? Are there spurious signals in the area? This is the device that you use to make those sort of measurements. And for $164, I mean, kind of a steal, really. Now, if you are somebody who, again, is into the amateur radio, high frequency stuff, or even medium frequency, FM broadcast, AM broadcast, then this doesn't go low enough to cover those frequencies. In that case, you would want the Tiny SA or the Tiny SA Ultra. All right. Now, guys, I would like to thank Banggood for sending this out to us free of charge for our consideration. And I will put a link down below where you can order one of these guys off of Banggood. And I do have an affiliate link, so if you buy one, Banggood will send me a few shekels. All right? Thanks for watching. That's it. I'm out. Peace.